Hello, I'm Eddie Knopp. I am the Chief Medical Officer for Hyperfine, the manufacturer of the world's first and only device-cleared ultra-low field point-of-care AI-enabled portable MRI device. Hyperfine has partnered with the Unity Project through funding enabled by the Bill and Melinda Gates Foundation to provide this groundbreaking technology to sites throughout the world in order to democratize healthcare and make things more accessible. The device itself can exist in a wide variety of environments, unlike conventional high-field scan. And the Unity project has approximately 40 to 50 scanners throughout the world, predominantly in the global south, with additional research support coming from academic sites, both in Europe as well as in North America. So the Unity project, through the use of collective minds, enables a community to be developed to understand the various imaging examples that are being obtained. This enables group understanding of pathology and of imaging, especially utilizing ultra-low field technology. The individual sites have the ability to upload cases to the collective minds database, and then they can be reviewed by anyone participating in this project. In addition, what we have done, and will continue to do so, is provide group discussions via webinar technology, where cases are uploaded, the entire group, whoever wants to participate, is there, and then expert review, primarily by myself, as a diagnostic neuroradiologist, trained here in the United States with a large amount of experience, reviews and discusses the cases with the additional clinical information provided by the individual sites. We've done this a few months ago and found it to be exceedingly helpful, not just to us on the Unity and Hyperfine side, but on the participants as well, as in addition to the Collective Minds database and the Collective Minds staff. So as an example, this is a case from the last webinar that we did that was uploaded from one of the Unity sites to the Collective Minds database, where there was a clinical concern and the site wanted both expert and the group's assessment of the images and the potential clinical situation. There was a concern for hydrocephalus, or pathologic enlargement of the ventricular system. And what we see are the ultra-low field images that were uploaded to the system itself. We have, in this window, axial T1 weighted imaging covering the child's entire brain. We can see the orbits here and the globes, fourth ventricle. We see the slight prominence of the arachnoid, subarachnoid space in the middle cranial fossa. And then as we come up, we see the supratentorial brain, sylvian fissures, and we're getting into the ventricular system. For a 27-month-old child, the ventricular system does look prominent, but there are certain criteria that I like to use to assess the size, whether it be pathologic or not, of the ventricular system itself. And we can let's look at the image sequences and then we'll discuss that. So this is an axial T1 weighted image. Here we have corresponding axial T2 weighted image. So now the CSF is white as opposed to being black, and the brain parenchyma is somewhat dark. And we have the same coverage itself. Importantly, we also see a coronal image coming from front. We have the globes to the back. We're also looking at basically the same thing. There's slight prominence of the subarachnoid and subdural spaces, and we see the ventricular system. We see the third ventricle, and we're going to see the third ventricle on all of these slices. And then most importantly, in my mind, is the sagittal image. Here we have a sagittal T2 weighted image where we're approximately in the midline. We can see the corpus callosum, and we can see the third ventricle in this region. What I like to do to assess whether there is ventricular enlargement or not, there are certain imaging criteria. On the axial plane, I like to look for the lateral boundaries of the third ventricle. If they're bowed out, that's clearly consistent with hydrocephalus. If they're slightly prominent, it may be somewhat iffy. We see here, and it's, I think, a little easier to see on the T2, given the tissue contrast, that there's a suggestion that maybe there is some outwards bowing or rounding of the lateral margins of the third ventricle. You get the same sense on the coronal image as well. And most importantly, and I use this primarily, is a slight upwards bowing of the corpus callosum. That to me indicates that there is increased fluid pushing up on the corpus callosum that shouldn't be there. Normally, the corpus callosum, which we see here, should have a somewhat flat appearance. Here it's upwardly bowing. So based on this, to answer the site's clinical question, is there some hydrocephalus in this patient? I would say yes. There is mild hydrocephalus, and the recommendation would be looking at the rest of the imaging sequences. There's nothing really to explain it, so it's kind of normal pressure hydrocephalus. There's no obstruction, and the recommendation would be, depending on the child's symptoms, to continue to follow this patient because it may resolve. And one last thing to end is our next upcoming webinar, which will be held on Wednesday, January the 29th at 6 p.m. Central European Time, or here in New York, that's 12 noon Eastern Standard Time. Any Unity participants, please upload new additional cases so we have some nice, interesting material to review. And remember that anyone can participate in this to learn about this amazing technology and how it's helping and democratizing healthcare throughout the world. Thank you.